Here's an example of a proton NMR. This is an example of the spectrum of ethanol. And let's look at the components, like the important features of the spectrum, and then in later videos we'll delve deeper into each of them. So the first thing to notice is that there are 3 signals. And so signals are, in some cases, split up into peaks. So the signal on the right is split into 3 peaks, and then there's one in the middle that's just 1 peak, and then split into the left, the one on the left is split into 4 peaks. And then you'll see these blue lines. You don't always see the blue line on the spectrum, but sometimes there are the blue lines, and what that is telling you is the relative number of protons of each type. And so one type is the protons of CH3. They're all equivalent, and we'll look at that at the next video. And so all 3 of them are represented by the signal. The OH, the proton there, is represented by the signal in the middle, and then the CH2 group is represented, or the protons on that CH2 group are represented by the signal on the left. So one of the things that we can do is figure out the relative number of protons. The second thing that you want to look at is where each signal is on the x-axis, and that gives you information about how close the protons are to electronegative elements and double bonds and other structural features. And then finally, the number of peaks that each signal is split into tells you about the number of protons on neighboring carbons. So when you look overall at your spectrum, the right-hand side is going to be referred to as upfield, left-hand side is referred to as downfield, and sometimes it's also referred to as shielded and deshielded. So one of the things, the final thing that I just want to note here is that you'll often see a peak or a signal at 0, and that is actually not a signal that's due to your molecule or from your molecule. That is from a reference that's added to many solvents, and it's called trimethylsilane or tetramethylsilane, pardon me, TMS, and it is arbitrarily set at 0, and then whatever we measure is relative to that.